Day 15 of 90. You copied a VPC module off a blog post, ran terraform apply, and shipped it to prod and staging. Here's the problem. That module opens 0.0.0.0/0 everywhere, skips flow logs, and leaves a hidden security group that allows all traffic between your resources. If one EC2 instance gets popped, the blast radius is your entire network. Today we build a lockdown, multi-tier VPC in Terraform that you can actually reuse without inheriting those gaps. Look at the bad baseline first. One flat CIDR, every subnet routed to an internet gateway, databases sitting right next to public web servers, and the default security group untouched. AWS created that default SG with an implicit allow-all between members. Attacker lands on a web box, and now they can reach Postgres, Redis, your internal admin panel. Nothing stops lateral movement. We fix this with three things: real subnet tiers, scoped flow logs, and a default SG override. Start with deterministic CIDRs. Don't hard-code them. Accept a single /16 as a variable and derive everything with cidrsubnet. In locals, public_cidr equals cidrsubnet of var.vpc_cidr, 8, the AZ index. Private gets a different offset, isolated another. Pair that with a data.aws_availability_zones lookup and for each over the AZs. Now the same module works in US, East, 1 or EU, West, 2 without editing a single CIDR. The copy-paste version hard-codes AZs and CIDRs and breaks the moment you change region. Now the tiers. Public subnets get a route table with a 0.0.0.0/0 route to an AWS_internet_gateway. Private subnets get their own route table pointing at a NAT gateway for outbound-only egress. Isolated subnets, your databases, get a route table with no default route at all. That's the whole point. The database tier physically cannot reach the internet gateway, because the route doesn't exist. Use explicit AWS_route_table_association resources per subnet. Don't rely on the main route table, associate every subnet deliberately. Flow logs next, and bake them into the module, don't bolt them on later. Create an AWS_CloudWatch_log_ group with retention_in_days set to 14. Then an AWS_m_role with the exact trust policy for vpc-flow-logs.amazonaws.com, and a scoped permissions policy. Create log stream, put log events, describe log groups on that one log group ARN. The common mistake? Attaching administrator access to the flow log role because it was easy. That role only needs to write logs. Wire it up with AWS_flow_log, traffic_type set to all so you capture both accept and reject. Here's the sneaky one. The AWS_default_security_group. AWS auto creates a default SG on every VPC, and it allows all traffic between attached resources. Terraform will not delete this resource, it can't. But you can adopt and override it. Declare an AWS_default_security_group block referencing your VPC_ID with no ingress and no egress rules. That revokes the allow-all baseline. Now nothing uses the default SG by accident, and if something does, it's deny by default. The rule, always override, never ignore. Want a guardrail in the module itself? Add a precondition. In a lifecycle block, write a check that fails the plan if any security group rule has cidr_blocks containing 0.0.0.0/0 on port 22 or 3389. Now nobody can reuse this module and accidentally expose SSH or RDP to the world. Terraform refuses to plan. That's enforcement inside your code, not a separate policy tool you hope someone runs. Prove it works. Run Terraform plan against the bad flat baseline and watch every change scroll by: subnets retiered, routes corrected, default SG locked, flow logs added. Then Terraform apply on a clean account, run plan again, and get no changes. Idempotent, reviewable, and the same module hardens prod and staging identically. Day 15 done. The takeaway: subnet tiers stop lateral movement, scoped IAM stops privilege creep, and overriding the default SG closes the gap AWS hands you for free. Subscribe for day 16.